So we were discussing about the nucleon number, and in the case of nucleon number, how we are going to describe nucleon number, the number of protons and number of neutrons present in nucleus is known as nucleon number. Known as nucleon number. और न्यूक्लियन नंबर को हम किस लेटर से रिप्रेजेंट करेंगे लेटर ऑन? न्यूक्लियन नंबर इज रिप्रेजेंटेड बाय कैपिटल ए, एंड न्यूक्लियन नंबर इट इज आल्सो नोन एज मास नंबर. इसको मैस नंबर भी कहते हैं. ठीक है, nucleon number is also called as a mass number as well. So you people are well aware about these terminologies. You have studied before, but ये recap करवाना मेरा फर्ज है. So this is a symbol which is known as lithium, symbol of a lithium, and there are two numbers written at the top. There is 7, at the bottom there is 3. So 3 is representing the atomic number. Atomic number भी आप इसको call out कर सकते हो. You can also call it out as a proton number as well. And the above one, 7 is representing you the mass number, or it is also known as nucleon number. So you are having one equation which you need to keep in your mind, and what that equation is, nucleon number is basically equals to nucleon number is equals to proton number plus, नीचे लिख देता हूँ, प्रोटॉन नंबर प्लस न्यूट्रॉन नंबर. जगह कम है थोड़ी, तो मैं यहाँ पे यूं मैनेज करता हूँ. न्यूट्रॉन नंबर. और आप इस तरह इसकी इक्वेशन को यूं भी लिख सकते हो, A इज इक्वल्स टू Z प्लस N, where N stands for number of neutrons, Z stands for proton number, A stands for nuclear number. So let's say if we are having, in the case of lithium, we are having a nuclear number as 7, and if we are having the proton number as 3, so what is going to be the number of neutrons? Number of neutrons will be nucleon number minus number of protons, and that will be equals to number of neutrons आ जाएंगे 7 minus 3 equals to 4. So how many neutrons this lithium is having? Lithium is having 4 neutrons. It is having 3 protons. So at times आपको एग्जाम में कहा जा सकता है कोई भी एलिमेंट देके कि just find out the composition of the nucleus of that uh, atom, or so on and so forth. Like we can have another one as well, uranium. Let's have one of the isotope of uranium, and uranium letter is written as, at the top we are having its letter as 238, and at the bottom, for instance, we are having as 92. So yes, any one of you can answer me, what is the atomic number of uranium? I'm just talking about this specific element. Yes, among you, can anyone just let me know what is the atomic number of the uranium?
92.
92. Very good. Uh what is the nucleon number of uranium? Yes, what is the nucleon number of the uranium? Can anyone tell me about it?
235.
238. This isotope is 238, right? So we are discussing 238 one. So this is going to be 238 is the nucleon number. Okay. If I need to find the number of neutrons in the nucleus of uranium, how I am going to find out from this figure?
We'd subtract the two values.
Very good. We are going to subtract the two values. The number of neutrons over here will be equivalent to what value? Number of neutrons will be equivalent to 238.
146.
238 minus 92.
146.
It will be equivalent to 146. So you should be knowing how to find number of neutrons, number of protons, and even if it is talking about a complete atom, so it can be asked about the electrons as well. Okay, if I say it is a neutral atom of uranium, what will be the number of electrons in it?
Would they be equal to the number of protons?
Very good. It will be equals to number of protons. So in a neutral atom, the number of electron and proton, they are same. आगे चलूं, ये बेसिक इन्फॉर्मेशन है, थोड़ी आपको पता होनी चाहिए. So proton number is also called as atomic number. Electrons are same as protons, and neutrons are just simply found by minusing, subtracting the proton number and the mass number. Mass number is also called as nucleon number. So this nucleon word also refers to mass number. Atomic number refers to proton number, and subtracting both of them, we will get the number of neutrons. Any problem to any kid? Shall I move on? All right, so I'm moving onwards. Next is, so let's see one of the example over here. There is one atom, might be it's an iridium. It is having 192 and 77 in its symbol, and it is a neutral atom. So question says, this appeared in one of the MCQ as well. The question says how many protons are there, how many neutrons are there, and how many electrons are there. So yes, can you let me know the number of protons in it? Who is going to tell me the number of protons? Yes, please speak up.
77.
Yes, the number of protons are 77. What are the number of electrons?
77.
77. And what are going to be the number of neutrons? How will be finding the neutron number?
Sir, it'd be 115.
Yes, it will be 115. How we fetch 115? Because it is found by subtracting 192 with 77. So 192 minus 77 will give us the number of neutrons. Good. Moving onward, okay, isotopes. Can anyone tell me what are isotopes? It's a old term. You have been studying it for several years previously as well. Can any one of you let me know what does the term isotopes means? Yes, please. Any clue about it? Be quick. No one? Okay.
Atoms having a different neutron number.
Yes, atoms, they're atoms of the same element, right? They are the different atoms. They're the different atoms, and these different atoms are of the same element, but they are having same proton number, but different neutron number. Or you can say they have same atomic number, but different mass number. So such atoms are called as isotopes. The very basic example for the isotope is hydrogen. Hydrogen exists in three isotopic forms. What are the three isotopic forms? It is called as protium, number one, deuterium, second one, and tritium is the third one. So we are having three isotopic form of hydrogen. Likewise, carbon exists into 2 to 3 isotopic forms. Similarly, uranium exists in multiple number of isotopic forms. There are so many other radioactive isotopes. They are existing in the isotopic form. Iron itself exists in isotopic form. So how we are going to define isotopes? Isotopes can be defined in these two, and these two definitions are very simple and they are very important with respect to the paper. So you can write atoms of the same element having same atomic number but different mass number. They are having same atomic number, but they are having different mass number. This is one of the definition. The other definition is written in this black. Isotope is an atom of the same element that have equal number of protons but different neutrons. And these are the examples of the hydrogen. Done? Chalo aage.
Yep.
I think this all is quite basic and you would have definitely studied it. But though it's a part of syllabus, so it's necessary to have its revision. Okay. So let's see an example how a question generally appears in exam. One of the rows in the table shows a pair of nuclei that are the isotopes of one another. So जी अब मुझे बताओ ये पेयर आपको शो हो रहे हैं दो न्यूक्लियाई के. ये एक पेयर है ये दूसरा पेयर है ये एक पेयर है ये दूसरा पेयर है ये एक पेयर है ये दूसरा पेयर है ये एक पेयर. सो और इनके इनके अकॉर्डिंगली लाइक जिसका न्यूक्लियन नंबर 39 है उसके नंबर ऑफ न्यूट्रॉन्स 19 है. जिसका न्यूक्लियन नंबर 35 है उसके नंबर ऑफ न्यूट्रॉन्स 22 एंड लाइकवाइज फॉर ऑल दीज थ्री ऑप्शंस. So which one is the correct row? कौन सी correct row बताएगी if they are representing the isotopes? If it is representing the isotope, which one is going to be the correct row? Who is going to tell me about this? Yes, anyone who can just tell me which one is going to be the correct row? So what does the term isotopes means? Isotope means that proton number in each case should be what? The proton number in each case should be same. The number of protons should be same in each possible case. So how we are going to just find out that which specific option is correct? Yes, anyone who can answer it out?
Is it B?
Huh?
B, the second
Yes,
option.
it's B. It's B. How we are going to fetch this B? We can see 37 is the nucleon number. To find out the proton number, you are going to subtract the neutron from it. So 37 minus 20 will be equals to what? 37 minus 20 will be equals to 17, right? And if we are going to subtract the 35 from 18, again, it will be representing the 17. And what the 17 is actually? The 17 is representing what? It is representing the proton number. And as the proton numbers are same, so correct row will be represented as B. Okay, moving onward, this was pretty simple. आगे चलता हूँ. न्यूक्लाइड नोटेशन. So yes, ये जो भी हमने किसी भी सिंबल को रिप्रेजेंट कर रहे हैं, किसी भी सिंबल को हम शो कर रहे हैं इन टर्म्स ऑफ इट्स न्यूक्लियॉन नंबर एंड प्रोटॉन नंबर, तो हर केमिकल, हर एलिमेंट का जो सिंबल है विच इज रिप्रेजेंटेड, टॉप पे हमेशा न्यूक्लियॉन नंबर होगा, बॉटम पे प्रोटॉन नंबर होगा. दिस केमिकल सिंबल फॉर ईच ऑफ द एलिमेंट इज कॉल्ड एज न्यूक्लाइड notation because we are just discussing with the nucleuses of the elements. So any nuclei which is written with its proton number and nucleon number is called as nuclide notation. Like for example, मैं आपको और एक दो nuclide notation लिख देता हूँ helium की. What is the nuclide notation for helium? You will be writing it as He. On the top there is 4. On the bottom there is 2. Likewise, we can have some other different elements as well. For example, we can further write it for carbon. Carbon 12 at the top and 6 at the bottom. So top पे हमेशा कौन सा number होगा? At the top we will be writing the nucleon number, and at the bottom what we will be writing? We will be writing the proton number. So proton number is on the bottom and nucleon number is on the top. So this representation, so representing any of the element in this specific way, it is known as, yeah, it is termed as nuclide notation. Any problem?
No, sir.
Okay, moving onwards. Yes, so always remember that in any sort of nuclear equation, what is nuclear equation? Nuclear equation is any sort of equation which is involving the nuclide notation. So like if we saw one of the fission reaction, I hope you remember the fission reaction. What is a fission reaction? It's a reaction in which two lighter nuclei join together to form, one heavier nuclei splits into a two lighter nuclei. It's called a fission reaction. So this is one of the reaction being shown. Uranium-235 and 92 is hit by the slow-moving neutron and it splits into strontium and xenon with an emission of 2 neutrons. तो इसमें देखने वाली क्या बात है? पूरी कोई इक्वेशन आपको याद रखने की जरूरत नहीं है, लेकिन इसमें एक बिहेवियर आपने देखना है. What behavior you are going to witness? You are going to see that the conservation of the nucleon number is taking place. What it means that in an equation on the left hand side, the sum of the nucleon number and the total number of nucleons on the right hand side will be same. For example, if I see this equation, what is the total number of nucleon on the left hand side of the equation? It is 235 plus 1, which is 236. And if we see the right hand side, on right hand side we can see the total nucleon number is again what? 90 plus 144 plus 2 multiplied by 1. So if we add all of this, that is equals to what? It will be equals to 236. So always remember the number of nucleon on the left hand side and number of nucleon on the right hand side will be same in any nuclide equation. This equation is called as nuclide equation. This equation is called as nuclear equation. So किसी भी nuclear equation में nucleon number और जो charge है वो conserve रहता है. इसी तरह हम charge पे भी देख सकते हैं. Let's say if we see the proton number, it is 92. प्रोटॉन 92 चार्जेस हैं, पॉजिटिव चार्जेस हैं, ठीक है. सो 92 न्यूट्रॉन हैज नो चार्ज, सो इट्स जीरो. राइट साइड पे अगर देखें वी आर हैविंग 38 प्रोटॉन्स प्लस 54 एंड जीरो इन दिस. So 38 plus 54 is again equals to 92. So the number of protons should be same on the left hand side as on the right hand side. Number of nucleons should be same as on left hand side as on right hand side. Is it fine? So any of the nuclear equation always observes the conservation of nucleon number and charge. So the charge, which is total charge present on the left hand side, will be equals to total charge present on the right hand side. The nucleon number, the total nucleon number present on the left hand side will be equals to total nucleon number on the right hand side. Is it fine? You please speak up ताकि आगे चलूंगा.
Yeah.
All right. So moving onwards, next term is the example. We are having one of the example. Let's see to it. For example, uranium, and there is one uranium, there is one neutron. They're hitting, they are forming one rubidium, one is cesium, and there is n number of neutrons. So question says that you have to find this number of neutrons. How many number of neutrons are going to be formed on the right hand side? So yes, can anyone give me a clue how we will be finding it out? Yes, please speak up how we are going to get this information, how we will be finding the number of nucleons on the right. Yes, anyone?
Total nucleon number is equal to 236, so we rearrange to find n.
Very good. We are going to just rearrange. We are just going to equate the total number of nucleon on the left hand side with the total number of nucleons on the right hand side. So total number of nucleon on left hand side is what? 235 plus 1, which is 236. And total number of nucleon on the right hand side is what? 96 plus 137 plus 1. So it sums up as plus 1 into n. So it sums up as 96 plus 137 plus n into 1, which is 236. To find out the value of n, we will be doing what? 236 minus 96 minus 137 whole divided by 1. So how many number of neutrons are produced in this whole reaction? The number of neutrons produced in this whole reaction is 3. So 3 neutrons are present, right? Moving onwards, there's another example. You can see that question says when a californium atom reacts with an unknown element X, the following reaction occurs. So what is the following reaction occurring? We can see over here, this is the reaction. There's a californium, an element with the nucleon number of 252, proton number of 98, plus there is an element X with nucleon number of 10, proton number of Y. It emits 3 neutrons. It emits one element which is called as Lr. It is having a nucleon number as Z. So question says you need to find out this Y on the left and Z on the right. Yes, any clue who can give me to find out Y and Z? Yes, please. कोई बता सकता है Y और Z मैं कैसे find करूंगा? Yes, anyone who can tell me how I am going to find out the Y and Z?
252 plus 10 minus 3.
Yes, 252 plus 10 minus 3 will be equals to Z. That will be equals to Z. And to find out Y, what I will be doing, 98 plus Y is equals to 103. So Y will be equals to 103 minus 98. So the value of Y will be 5. So Y will be found as 5 and the Y will be found as 5 and Z will be found as 250. What is the value? 259. It will be found as 259. I hope everyone is getting the information, whatever is being discussed here. Ji, please, I need the acknowledgement. Are you people getting the things?
Yes, sir. Yeah.
What about the others, please? I need maximum acknowledgement.
Yes, sir.
Yes, sir.
Yes.
All right. So let me move onwards. The other thing we are going to discuss is all right. Yes, we will be discussing about these radiations. Can anyone tell me what is the meaning of radioactivity? Yes, anyone can tell me what is the radioactivity? Can anyone give me a clue about it? What does the term radioactivity means? Yes, please. Anyone who can give me a clue about
Emitting
radioactivity?
particles.
Yes,
Sir, is it when like nuclear particles decay?
yes, nuclear decay happens. That is happens in the radioactivity. Okay, I haven't written its definition over here, but let me recall its definition over here. That is called as radioactivity. What does the radioactivity means? Like naturally in nature, uh, in this earth or in this universe, there are certain elements present which are having unstable nuclei. So what they usually do or what they try to do, they try to convert those unstable nuclei into more stable form. So whenever any unstable nuclei try to convert itself into more stable form, they emit few radiations. And what radiations are being given out? The radiations given out during this process is known as alpha ray, beta ray, and gamma rays. So what is radioactivity? I can just write it down over here. The process, the random process, I do believe. The random process in which unstable nuclei converts itself into more stable nuclei with some emission of radiations is known as radioactivity. Such behavior or such phenomena is known as radioactivity. So the concept of half-life and detailed discussion of the decays and so on and so forth, we will be discussing them. Yeah, you will be studying them in the A2 physics as well. But a few of the basic information regarding the emission of the particles is a part of a syllabus over here. So what is radioactivity? It's a random process in which the unstable nuclei convert themselves into a more stable one. And with this conversion of unstable elements into a more stable one, it is emitting three types of rays. What are those three types of rays? They are called as alpha ray, beta ray, and gamma ray. So in radioactivity or as a result of radioactivity, always these radiations are being produced. So how the alpha is being represented? Alpha is represented by this symbol, beta is represented by this symbol, and gamma is represented by this symbol. These are the symbols for each of them. And by the way, there are two types of beta radiations which are going to be emitted. One of the beta radiations which are emitted, they are going to be negative, and there are some certain beta radiations which are going to be positive. So two types of beta radiations are emitted in whole of this process. So during radioactivity, these three rays are being produced, alpha, beta, and gamma. So now one on one, we are going to discuss the properties of their radiations which are given out during the process of radioactivity. So the radiations which are being given out during the process of radioactivity, the very first is alpha particle. So what are the properties or the composition of alpha particle? Alpha particles are high energy particles. They are made up of two protons and neutrons. They are actually same as helium nucleus. So it is very important to understand what is an alpha particle. Alpha particle is a helium nuclei. If someone asks what is alpha particle is helium nuclei. Why we are saying it helium nuclei? Because the nucleus of an helium is also containing two protons and two neutrons. Likewise, alpha is also containing two protons and two neutrons. So usually their mass is more, so they are deflected in electric and magnetic field. What it means, like when they are moving in the electric and magnetic field, they are going to get diverged, their path changes. They have very strong ionization ability, they have very weak penetration ability, their speed is very less in air, and they have very short range in air, and they can be stopped by a piece of paper. So these are the different properties for the alpha particles. Yes, any problem in it? Is any confusion over there? Shall I wait for you or move on? Yes, please speak up. Shall I wait or आगे चलूं?
We're done.
Okay. Next is beta particles. So what are beta particles? बीटा पार्टिकल्स आर एक्चुअली दे आर हाई एनर्जी इलेक्ट्रॉन्स। ये अभी मैं कौन से बीटा पार्टिकल्स की बात कर रहा हूँ? आई एम टॉकिंग अबाउट द नेगेटिव बीटा पार्टिकल्स। द बीटा पार्टिकल्स आर पॉजिटिव एज वेल। सो what are the beta particles? They are the high energy electrons, they are high energy negative charges। और इलेक्ट्रॉन्स हमें पता है कि इलेक्ट्रॉन पे चार्ज क्या होता है, नेगेटिव होता है। तो सिंपली हाई स्पीड नेगेटिव इलेक्ट्रॉन्स जो मूव कर रहे होते हैं, दे आर रिप्रेजेंटिंग द बीटा रेडिएशंस एंड दे आर ऑल्सो एमिटेड बाय द न्यूक्लियाई एंड दे आर मॉडरेटली आयनाइजिंग, यानी कि इनकी आयनाइजेशन एबिलिटी जो है वो कम होती है अल्फा से बट ज्यादा होती है गैमा से। और क्यों ऐसा होता है? बिकॉज दे आर हैविंग लेस अमाउंट ऑफ चार्ज ऑन देम and they also just have very small damage to the cell because of their medium ionization ability। अच्छा, इनकी penetration power जो है वो अल्फा पार्टिकल से ज्यादा होती है but it is less than the gamma particles। What is the meaning of penetration ability? Penetration ability means to get past through certain any object or any hindrance। So किसी भी hindrance में से pass through कर जाना, it means that the body is able to penetrate through it। So it is having a moderate penetration ability। Next is it can be stopped by a few millimeter of aluminium। So आप aluminium foil से beta particles को या beta particles के अगर रास्ते में रख दी जाए, so you can stop those beta particles। And next, last but not the least, we are having gamma particles। What are gamma particles? They are high energy electromagnetic waves। They are actually form of photons, right? Radiations। So they carry no charge। इनके ऊपर कोई charge नहीं होता। And plus they are not deflected in electric and magnetic field। ये बिल्कुल स्ट्रेट चली जाती हैं। इनकी पेनिट्रेशन एबिलिटी सबसे ज़्यादा होती है, इनकी आयनाइजेशन एबिलिटी सबसे कम होती है। और ये जो पार्टिकल्स हैं दे आर नॉर्मली बीइंग यूज इन द ट्रीटमेंट ऑफ कैंसर एज वेल। इनकी रेंज इन एयर सबसे ज़्यादा होती है, इनकी स्पीड इन एयर सबसे ज़्यादा होती है। एंड दे कैन ओनली बी स्टॉप्ड बाय लेड एंड कॉन्क्रीट। So let's see the comparison between all these particles। अल्फा पार्टिकल में 2 प्रोटॉन 2 न्यूट्रॉन, इनका मास जो है वो 4 टाइम्स ऑफ एटॉमिक यूनिफाइड मास है। इनके ऊपर टच चार्ज जो है +2 होता है। इनकी जो स्पीड है इट इज 0.05 टाइम्स ऑफ द स्पीड ऑफ लाइट। Likewise, beta minus particles are electrons। Their speed is 0.0005 times of u। They have relatively -1 charge and it is nearly near to the speed of light। And likewise, beta positive particles are also produced। Positive particles are called as positrons। Positrons are having the positive charge. Their speed is similar to the speed of electrons and they are having a charge of positive and their speed is like nearly less than the speed of light. And last but not the least, we are having the gamma rays। Gamma rays are electromagnetic waves. They carry no mass. They are massless, they are chargeless, and their speed is same as the speed of light। So let's have a more comprehensive difference. Let's see the more comprehensive difference between all these particles। So what comprehensive difference we can see among all these particles? And you need to learn all of them। So what is the nature? Alpha is helium nucleus। Beta particles are fast moving electrons, beta particles are fast moving positrons। Beta particle beta particle positive is an antimatter of the beta particle negative। And likewise, the gamma particles are the high frequency electromagnetic radiation। And next, what is the charge which is present? The charge present on it is what? The charge present on the alpha is +2e, on beta negative is -1e, on beta positive is +1e, and on gamma there is no charge। Mass is 4u, its mass is 9.11 to 10 power -31. How it appeared? You need to just multiply it by 0.0005 with 1.66 in 10 power -27. So you will be getting this value. Likewise, the charge on positron is this. There is no charge on, then there is no mass of gamma।
We need to memorize the mass.
Yes, yes, yes. You need to memorize the mass. This mass? You need to memorize these values of mass. See, what are the values of mass? For alpha, it is 4u. What is the meaning of 4u? We just studied it. 4u. U stands for unified atomic mass. So 4u means what? The 4u is same as 4u meaning what? 4 multiplied by 1.66 into 10 power -27। ठीक है, it will be equals to what? 1.66 into 10 power -27। This is the mass. So when you're going to multiply 4 into 1.66 into 10 power minus 27, you will be reaching up to its mass. Likewise, for the mass of electrons, you need to multiply it with 0.0005 because this is the mass of electron. The beta particles are electrons. The beta positive particles are positrons, which are sort of considered as positive electrons, right? The positive elementary charge they are having. So no big deal in memorizing them. Likewise, symbol is going to be alpha, beta, beta, gamma. For beta negative, you will be using -1 at the bottom. For beta positive, you will be using 1, and gamma is this way. Penetration ability, alpha is having least penetration, beta particle is having moderate, and gamma is having highest penetration ability, and they can be stopped by lead or a concrete wall. Ionization ability, highest for alpha, lower than alpha for the beta particles. For positrons, it is very less, and the least one is for the gamma one. Its range is lowest in air, its range is greater. Again, positron's range is also very low, and the range of gamma is greatest. And last is the speed. Alpha particle is having a speed of around 10 power 6 to 10 power the factor of 10 power 7 meter per second, whereas for the speed of beta particles, they are near to 3 into 10 power 8. Rest, the gamma particles are having the speed of 3 into 10 raised power 8 meter per second, and this speed is equivalent to the speed of light. So gamma particles are electromagnetic waves, and all the electromagnetic waves are moving with the speed of light. Is this comparison fine? You can just learn them out, like keeping the things in mind. Yes, please speak up.
Yes, sir.
Okay. Moving on, or ये आपने generally you have already studied in your previous year as well. तो एक quick like recap भी हो रहा है alpha, beta, gamma particles का. Okay, moving onwards, let's see neutrino emission. What does the word neutrino emission means, and how this neutrino, or from where this neutrino comes, and so on and so forth. So we are just discussing that in radioactivity, what happens? Some unstable nuclei convert themselves into more stable nuclei, right? So when they're converting from unstable nuclei to more stable nuclei, what they are actually doing, they are emitting certain radiations. So let's say if there is a happening of beta decay, if there is a radioactivity in which beta particles are produced, or if there is a decay in which beta particle is formed, in such case with beta particles, some new subparticles or subatomic particles are also formed, and those subatomic particles are called as neutrino. Normally इनका पूरा नाम है इलेक्ट्रॉन न्यूट्रिनो. सो न्यूट्रिनो जस्ट लाइक वर्ड है हमारे पास न्यूट्रॉन, एक और हमारे पास सब एटॉमिक पार्टिकल आ गया न्यूट्रिनो. सो न्यूट्रिनोज जो है वो प्रोड्यूस होते हैं बीटा पार्टिकल की एमिशन में. जब भी बीटा डिके होगा उस वक्त ये न्यूट्रिनोज पैदा होंगे. और इलेक्ट्रॉन न्यूट्रिनो इज अ टाइप ऑफ सब एटॉमिक पार्टिकल जिसके ऊपर कोई भी चार्ज नहीं होता, और इसका जो मास है वो भी ना होने के इक्वल होता. So it is having negligible charge, it is having negligible mass, and it is emitted from the nucleus. So again, जैसे हमने बात की थी मैटर और एंटी मैटर की, तो न्यूट्रिनो का हमारे पास एंटी मैटर क्या होगा? The antimatter of neutrino is going to be anti-neutrino. So you need to recognize whenever there is a beta negative decay. What is बीटा नेगेटिव डिके? ऐसा डिके जिसमें इलेक्ट्रॉन्स पैदा हो रहे हैं, जिसमें इलेक्ट्रॉन्स प्रोड्यूस हो रहे हैं एज अ प्रोडक्ट. तो उसके साथ साथ क्या निकलेगा? देयर इज गोइंग टू बी एन इलेक्ट्रॉन एंटी न्यूट्रिनो. there is a production of electron anti-neutrino. And when there is a beta positive decay, in the case of beta positive decay, there will be a production of electron neutrinos. So in the case of positive decay, there will be electron neutrinos. In the case of beta negative decay, there is formation of electron anti-neutrino as well. So how we are going to represent the symbol? What are the symbols for the electron anti-neutrino and electron neutrinos? So the symbol for electron neutrino is VE, V for neutrino, and E for electron. So VE is representing electron neutrino. And what is the antimatter of electron neutrino? It is anti-electron neutrino, which is VE, and there is going to be a bar at its top. A horizontal bar at the top will be representing anti-electron neutrino. So we are having two neutrinos. One is called as electron neutrino, other is called as anti-electron neutrino. What is anti-electron neutrino? It will be as VE. At the top, there is going to be some horizontal bar. Is this clear? मैं इसको एक क्विक वे में छोटे वे में समराइज करता हूँ. तो जब भी रेडियो एक्टिविटी हो रही होती है, और रेडियो एक्टिविटी की भी एक स्पेसिफिक टाइप है जिसमें बीटा डिकेज, बीटा पार्टिकल्स एमिट हो रहे हैं. अब हमें पता है बीटा पार्टिकल दो तरह के एमिट हो सकते हैं. या बीटा पार्टिकल पॉजिटिव एमिट होंगे या बीटा पार्टिकल नेगेटिव एमिट होंगे. बीटा पार्टिकल पॉजिटिव होते हैं पॉजिट्रॉन्स, बीटा पार्टिकल नेगेटिव होते हैं इलेक्ट्रॉन्स. तो अगर एक रेडियो एक्टिव डिके के एंड पे इलेक्ट्रॉन्स एमिट हो रहे हैं तो उसके साथ एक पार्टिकल प्रोड्यूस होगा विच इज कॉल्ड एज इलेक्ट्रॉन एंटी न्यूट्रिनो. और ये जो दोनों पार्टिकल्स इलेक्ट्रॉन एंटी न्यूट्रिनो, इलेक्ट्रॉन न्यूट्रिनोज, ये ऐसे पार्टिकल हैं जिनका ना तो कोई चार्ज होता है और ना ही इनका कोई कोई मतलब सिग्निफिकेंट मास होता है. ये बस समझ लें कि एक बाय प्रोडक्ट से पार्टिकल्स जो हैं वो प्रोड्यूस होते हैं. और इनके सिंबल, वन इज रिप्रेजेंट बाय वी, द अदर इज रिप्रेजेंट बाय वी एंड द बार एट इट्स टॉप. You need to memorize them. All right, so
Sir,
one,
what's the difference between a neutrino and an anti-neutrino?
all right, so I'll just answer it in the next session because it's only 1 minute left. So just rejoin in it, okay?